screen. Give me a second. All right, can y'all all see it?
Yes.
All right. So this is question 2. Let me just read it real quick in case y'all haven't seen it yet. So Bill is a programmer who loves to spend his free time watching the stock market. He carefully buys and sells stock daily so he can maximize his earnings. However, the stock market is unpredictable and the prices fluctuate often, causing Bill to gain or lose large amounts of money. Given a list of Bill's total earnings from his investments every day, find the contiguous block of days that Bill made the most earnings. If there are multiple contiguous blocks that maximize his earnings, find the block that starts earliest. If there are still multiple solutions that maximize Bill's earning and start at the same time, pick the one that ends earliest. In addition, Bill wants to invest in stocks for at least one day no matter what, even if that means losing money. So the input format is as such. You have all that. We don't care about that too much. And let's look at the constraints real quick. So if you want full points, that means that n is going to be less than or equal to 10 to the 6, and m of I is going to be between 10 to the 4 and negative 10 to the 4. So if you multiply these two numbers together, because you might have to, like, for example, add all the numbers together, or do things like that. That might be some pretty big numbers, you know? So like 10 to the 6 numbers that are around size 10,000. So each number, so like the total sum of all these numbers, for example, would be 10 to the 10, which means we probably have to work with longs instead of integers. So that's one thing we can notice when reading the constraints. Now the output format, we just output the maximum amount of earnings from a non-empty contiguous block of days. So for example, if we have this sample input 2, 5, so this 2 represents the number of cases, and this first 5 represents the number of days he invests in this first case. And then here are the amount of money he makes each day. And then 5 here is the number of days he invests for the second case. And then again, this is the amount of money he makes per day. So let's think about how this works. So if Bill invests for like some amount of days, right, then we want to find the maximum contiguous block of profits that he makes. So let's say like this is the maximum block, right? So he makes like the maximum profits in this block of days. Like let's just say like this is some block of days. That means that afterwards over here, this is going to have to be like negative, right? This is going to have to be negative, and this is going to have to be negative, like some block after. Otherwise, this wouldn't be the maximum because you could just add the next one, and that would be even bigger. So that means there has to be negative surrounding both. So that's an immediate observation after reading the question. Now let's continue looking at this. So you might wonder, like, when is it like not a maximum? Like when can a block not be maximized? Well, you know that if there's like a minus block here, then there could be like a plus block after, right? Like this block could be a plus, and then this whole thing would be a maximum. The only way that this could not be a maximum is that if at some point, if at some point the running total is 0. So for example, let's say you have max and then this minus block, right? So if we take this part over here, if this running total is equal to 0, that means that after this, Bill's total sum will be negative from here to here, which means we can just take this positive block instead of taking this whole thing, and that would be a maximum. So in reality, what we want to do is find where the total sum is 0 in like a running block, because that means that it cannot be a maximum afterwards. So basically, instead of like in the bunch of days that Bill invests, we can separate that into a few blocks where his running sum is equal to 0. So for example, if this is equal to 0, we can separate it into a block and then find the maximum in here. And then if this is equal to 0, we can find like this is like another block, and so on and so forth. We'll just have a lot of 0 blocks is what we can call them. Because again, in a 0 block, if there exists like some maximum positive value somewhere in this block, right, then there can't exist one overlapping in both blocks, because eventually this will equal 0. You kind of see what I mean. So let's put this into code. So first of all, we notice that we have to enter a lot of numbers. Like there's going to be 10 cube numbers for each case, and that might be quite a bit. So especially because they're like longs. Actually, no, n is between 0 and 10 to the 6. There might be 10 to the 6 numbers, which is even more. So instead of using scanner like we normally do, let's use buffered reader. So buffered reader is something that basically it makes inputting numbers, inputting strings, all of that a lot quicker. I'm not going to explain the specifics of that because Daniel's going to go more in depth in that for the next problem. Let's just use it for now. So this is how we create a buffered reader. New input stream reader system.in. Again, don't focus on buffered reader too much. Let's just I guess black box this until Daniel explains the next problem. So int c again is the number of test cases here. So here's 2. So int c is integer dot parse int input dot read line, and this is just like the format I use for buffered reader. Now let's create a for loop to parse each of these cases. So now at the beginning of the case, we take the number of days that Bill invests. So we input this number n. So we put int n equals integer dot parse int input dot read line. Bam. And then next of all, we need to parse these. We need to read these numbers. So these numbers again, there's going to be n of those. So let's just create a new array. So long earnings equals new long n, and then we can just for int j equals 0, j is less than n, j plus plus. Oh, and again, this is just something with buffered reader, but like, yeah, I have to create a string tokenizer here. So string tokenizer st equals new string tokenizer input dot read line. Again, don't worry about this too much. It's just for input purposes to make it a bit quicker. So then here, earnings j would be equal to integer dot parse int st dot next token. All right, so now that we have this input out of the way, let's figure out how to code and actually solve the problem. Well, using what we know earlier, like the 0 blocks, we can actually formulate a technique. We can actually formulate a way to solve this. So let me just, is there a way for me to erase all this? Let me just see. Okay, I can make a new one. Create. Yeah, so let's say we're looking at some numbers, right? So we start parsing through each of these, right? And eventually we can find like a running total, a running maximum. So for example, this is like 5 and 10. Then the maximum for this would just be 5, right? And then after you parse this, it would be 15, the maximum sum. Or let's say over here we have a -5. The maximum for these 3 would still be 15 because the sum is 10. But let's say after that we have a -20. Then the total sum of this is going to be -10. Suddenly, because the total sum is below 0, we don't want to use this block anymore. So we can basically just cut this out because no maximum sum outside of this will use this block, because accessing these positive numbers will mean like when you have to take the negative numbers, which is going to be a net negative either way. So next of all, so then after that you would just reset your total running sum. So for example, this is 3, then your running sum would be 3 because you know you can't use any of these numbers, and you would just keep going. So like if this is 5, then your running sum would be 8. And like if you have like 13 over here, then your running sum would be 21. And since that's bigger than 15, then your maximum would be 21 here. So if y'all see what I'm doing, I'm going to put that into code. Basically, I'll explain it as I code it again. So let's start with creating a long sum. So this is just going to represent the current sum. So for example, 5, 10, and then it's going to be, 5, 15, 10 minus 10, and so on. This is going to represent the current sum. Let's also create a max sum. So we could put this as 0, but remember that Bill has to invest at least 1 day, as it says over here, which means that the maximum sum can't be initialized as 0. For example, if every single day Bill loses money. So like if he makes -5, -10, -15, -20, -25, the maximum sum isn't going to be 0. It's going to be -5, which means we can't initialize it as 0. It has to be, so let's say it's earnings 0. Now, the question also asks for the positions in which Bill makes the most, the positions of the blocks in which Bill makes the most money. So let's just create some variables. So int max start. So this is going to be the start of the block. And at the moment, since the maximum block is just from starting at the 0th element and ending at the 0th element, the max start is just going to be 0. Same for max end, the end of that block. And now finally, let's create a variable representing the current starting point. We're creating this mostly so we can, so like when we want to update the max start, we have a variable to go back to, because for example, cur start and the current element you're on, for example, let's say I'm on 13, but then we need another variable to store where the position of this 3 is, because that would be cur start. So that's why we're keeping that. Now finally, to solve the problem, let's do a for loop going over every single one of these numbers. Again, like just doing the algorithm I described earlier. We start at each number, we keep going on, and if we get below 0 as a sum, we can just like cut everything out and reset and then start again. So let's start doing that. So first of all, our sum will be updated by adding each day's earnings. So for example, in the beginning, we update by adding 5, which is the first day earning, then 10, the second day's earning, so on and so forth. So we're going to do that no matter what. Now, if the sum is greater than the maximum sum, we obviously want to update the maximum sum. So if sum is greater than max sum, then we're going to update the max sum. So max sum would be equal to sum then. And then in addition, max start is just going to be equal to cur start, which is the variable for like where our current block starts. And then max end would just be j, because so far this current element that we're on, j, would be the last one we're covering. So like for example, if it's 5 and 10, then when we parse 10, j is going to be equal to 1, and that's the current element we're going. So that would be max end, the end of the current block we're looking at. Now, the other thing is, let's say the current sum is less than 0. Like for example, if our sum is over here, right, and our current sum is going to be -10, then again, we want to just cut this block out. So let's do that. We can just simply reset the sum because the sum would just be 0 if we don't take anything in this block. So let's just say sum equals 0. And in addition, we have to reset cur start, because cur start represents where our current block starts. So before, our block would start at this 0th position, but now we wanted to start at the 4th position, since we don't want to take into account any of the first 4 elements, since they would contribute a net negative factor to the total sum, which means that we would just write cur start is j plus 1, because that's the next element from where we're looking at right now. Like for example, at -20, we'll realize that sum is less than 0, which means we want the current start to represent the position which the 3 is at. So this is basically the entire code. Let's just do in simple input.close. And now, oh yeah, don't forget to output the actual answer itself. So let's use system.out.println. Let's see. So it says first we have to output the max sum. So this would just be this. Then we would have to output the starting position of this maximum block. So that's max start and then max end. So this is just how it's going to work. Let's just make sure this is in the right for loop. Yep, it is. So let's save and let's submit this code and see if it works. Okay, there's a compilation error, so let's look at it real quick. Let's see. So is there anything wrong we did here? One important thing.
Andrew, I think it's line 13.
Line 13. All right.
Read line should be the read should be lowercase.
Oh, that's my bad. Yeah, I accidentally did the uppercase. Thanks. So let's just see if this works now. And yeah, as you see, all 3 cases were accepted. And actually, if you use scanner instead of buffered reader, the cases would not be accepted. Like your program would be too slow because you had to read too many numbers, which is kind of troll, I agree. But I guess it's something to show that like how buffered reader really is like really important and time saving in cases with like a lot of inputs like these. So I think Daniel's gonna explain this problem next and also explain what buffered reader, like how buffered reader works. So y'all are able to like conceptually understand it and be able to use it in actual problems.
Also, before wait, first of all, if you have any questions about his solution, you can ask them.
Mhm.
Bef but first, before we go into the third problem, I have this link to a Google form that will basically ask you what languages you're comfortable with us teaching in. Because in this meeting we're doing all Java because like in like CS2 and CS3 you learn Java, so it's like it was safest for us to start in Java. But we also want to know if you'll be open to us teaching in like C++ and Python in the future. So fill that out if you want to like see more different languages being used.